Welcome to Speaking of Service, the podcast that uncovers practical ways to grow service revenue, control costs, and improve customer satisfaction. If you're looking to innovate, gain a competitive edge, or just learn about the latest service trends, you've come to the right place. Today, Chris Wolf, VP of Strategy Partnerships, joins Jeffrey Miller, Director of Digital Performance Management at Calypso. Jeffrey will speak to the topic of condition-based maintenance and how companies in the industrial sector can learn from military and defense when it comes to service operations.
Welcome to Speaking of Service. It's nice to see you back again. As a listener of this podcast, you know intrinsically that technologies that enable data and analytics can make your services delivery more cost-effective, create better customer experiences, all kinds of good stuff. But as a provider of service, how do you know if you're doing enough? How do you benchmark yourself against best practices? What kind of a framework do you use in order to measure your service delivery against the best? Way back in 2002, it's kind of a coming-of-age story, the Department of Defense set out to understand just how effective they were in delivering service and availability of complex machines in harsh environments, as you can imagine. They created a framework and a set of guiding principles on condition-based maintenance that has relevance to the private sector. I've asked an expert in that field, Jeff Miller from Calypso, to join me here today to talk about how laypeople and the civilian sector can apply some of these DoD principles. So Jeff, thank you so much for being here. Welcome to Speaking of Service. Tell our listeners a little bit about yourself.
Well, thanks very much for the opportunity to speak with you, Wolfie, and with your audience. I'm delighted to be here. It's good to see you. My name is Jeff Miller. I'm a director in Calypso, which is the digital business unit of Rockwell Automation, one of the world's leading providers of industrial automation, distributed control systems, and motor controls and the like. I've been in this space for most of my career. I'm an engineer by training and have been at this intersection of supply chain logistics, field service, manufacturing, and importantly, the technologies that drive them for the better part of 30 years. And this is a very interesting topic because it leverages so much of what's new in technologies today. So I'm looking forward to the chance to speak with you and your listeners about it.
Well, thanks, Jeff. So take us back, to those early days. Help me as a layperson understand what the DoD's ambitions were in creating this framework in the first place and how that's played out in the availability of the equipment that they maintain.
The U.S. Department of Defense, like every Ministry of Defense around the world, is concerned with the availability, the readiness, and the reliability of its assets, whether it's transportation assets, weapon systems, or anything else. Around 2002, the Undersecretary for Material Logistics and Acquisition penned a guidance piece that introduced the concept of condition-based maintenance plus. The plus being meant to focus on the use of data and analytics, all towards the goal, measurable goal, of improving the availability, readiness, and reliability of the assets that were of concern. And the way they were going to measure this was, besides those three, what were the costs in labor and maintenance and spare parts and logistics? So they had a rubric basically to say, by which to evaluate these initiatives. It was all towards the goal of increasing those three things: availability, readiness, reliability.
And how would they gather that information back in the days? I mean, now we take it for granted that we've got monitoring technologies, but was it a pen and a clipboard, I imagine?
Well, that was the key. I think with the advent of the plus, this was in the early stages. If we think back to where we were 22 years ago, 21 years ago, with regard to connectivity and the ubiquitous availability of data, these things weren't there. And so this was groundbreaking at the time because it required new forms of data collection, even new forms of communication of data securely. And then even with the analytics, these were immature at the time. We did have large computer programs and algorithms, but it wasn't as mainstream as it is today. So it really was groundbreaking at the time and imposed some challenges both on the government and on the industrial base, the defense industrial base that we were manufacturing these systems of concern. So I think that's the important point. Were we to do that today and come up with this idea today, if we hadn't yet done so, it'll be far easier to implement because of those things like connectivity that didn't exist back then.
So now fast forward maybe another 10 years or so. Where did they land kind of along this journey, and help us understand the trajectory they've been on ever since?
Sure, sure. I think it's helpful to go back to sort of the base principles of maintenance. There are three kinds of maintenance: breakage maintenance, or run to failure; preventative maintenance, where you sort of programmatically say every so often, every many months or weeks, we'll perform a series of maintenance procedures; and then condition-based maintenance, which in my view and definition enables predictive maintenance or algorithmically based maintenance. So that's the maturity model. Arguably, we had mostly preventative maintenance, not a lot of condition-based or certainly predictive maintenance back in 2002. But in the ensuing, as you say, a decade or so, the technologies began to evolve, and the connectivity necessary to share data about what was happening to an asset, a generator, a forklift, an airplane engine, an air handler on a building, or a weapons system in the case of the Department of Defense. All of these grew. The difference with the DoD was really how far-flung assets were all over the world, the complexities of servicing those. So the need for analytics data was much more valuable, perhaps, in that setting than it was anywhere else. And that was what I think spurred the growth into CBM Plus and this early idea of a digital thread that sort of connected all these pieces together: suppliers, maintainers, with the asset itself. That's what happened from 2002 to, say, 2012 or 15.
And now we know that data is everywhere. Data is the new oil or the new sunshine, depending on who you ask. How are the best companies making use of their data today for condition-based maintenance?
Well, if you run out to the end of the maturity model to condition-based maintenance and its associated predictive maintenance, which now invokes algorithms, either algorithms around models, so you have model predictive capabilities, or just around processes themselves, the leading companies are not only looking at analytics around patterns of how the asset performs in certain conditions, but they're also beginning to connect. This is the digital thread portion, Wolfie. They're beginning to connect what they learn from the data with other parts of the value chain, all of which contribute to maintaining it at a high level of availability or reliability. Readiness and availability to the Department of Defense and the defense industrial sector is sort of analogous to service level agreements in the civilian sector. When you buy a piece of agricultural equipment, or you buy an air handler on a roof, if you do actually buy the air handler, there will probably be a service level agreement associated with it: minimum time to repair, time between breakage events. So now companies are using analytics, as are the defense industrial companies, much more aggressively. One could argue this was really spearheaded by the defense industrial base, but now, because of connectivity and the ubiquitous nature of data, most companies are doing that. And the leading ones build models around that to predict when events are going to occur and to connect other pieces of the supply chain. I'll give you a very quick example. One of the airframers, and there are several around the world, so it can be any one of them, had a product associated with basically aircraft health, everything but the engines. And what they were trying to figure out how to do was to make this more valuable. What they ended up doing was connecting the monitoring system to assets and building algorithms to predict failure. And they also, on the back end, connected that system to the providers of maintenance services, MRO services, parts, and they also connected it to dispatch so they would know where the aircraft was when it could be repaired. The point in that example, and there's much detail around it, was simply to say that doing condition-based maintenance and predictive maintenance enabled them to keep the aircraft in the air much more efficiently without a corresponding increase in cost, because they could connect these various components of the value chain together. That's where the leaders are and where much of the work is: AI, machine learning, and supply chain connectivity.
Jeff, if I'm a business person trying to improve the profitability of my business, I mean, this creates an awesome opportunity for me to provide aftermarket services. And yet I probably have a population of machines in the field that have spanned these generations that we've spoken about. How are the best companies kind of sticking their toe in the water, maybe earlier in the maturity curve, and yet also capitalizing on some of these new technologies? How do you manage that portfolio?
The preventative maintenance piece is about parts and locations and speed to repair and programmatic maintenance. And that's never going to go away. That's really the foundation. I don't know any company who I speak with who operates assets on a run till failure basis. That's just not economically viable for the machine or for the satisfaction of the user. So pretty much everybody has some form of preventative maintenance. The investments are in the moving to condition-based and predictive, and they're usually paced by the availability of data. Are those assets properly instrumented? Were they instrumented by the OEM? Lots of OEMs are doing that now, and this is not new, have been putting sensors for wider ranges of data collection, especially in more complicated assets. They'll put many, many more sensors and many more capabilities associated with data collection on the device so that we can build these programs of condition-based maintenance, reliability monitoring. And again, there's a convergence here of reliability into this as well, so that we can build better maintenance models and then sell them to the consumer or to the owner of that asset. So from the owner's side, it becomes a decision about who to buy from sometimes, or what third party to engage to help pull these data together. That's where the economics come out for the owner, operator, lessor, if it's rental equipment, and for the original equipment manufacturer. Everybody sees value in keeping the asset operating, and depending on where you are in the value chain, it can be a compelling economic model.
Calypso are leaders in this field. And when you take a look at the customers that you're serving, how many of them are wanting to be the general contractor, providing a system of systems to collect data from all the disparate machines that they offer? How many of them lean more heavily on the data provided directly to them by the OEM maker?
There's certainly an industry, Wolf. It varies by sector. In the aviation industry, of course, and PTC is well in the middle of this as well, there's a very robust MRO industry in and of itself. And these are big beneficiaries of data and of the algorithms that go with predicting failure modes and setting strategy associated with that. And that's been around for many, many years. MRO in aviation as an industry is not new. It predates all of this. But its effectiveness and the profitability, while at the same time improving the availability of the asset, whether it's in aircraft in-flight entertainment system, or galleys, or gear, or engines, or flight control systems, all of this has been improved for the owner operators, for example, while still managing to create a very profitable enterprise for the providers of MRO, maintenance, repair, and overhaul services, and spare parts. Whole networks of providers of spare parts have sprung up. This is true in other industries as well. We still see most clients, either the companies that operate large fleets of assets, manufacturers or field assets, or the OEMs themselves being the principal purchasers of these technologies. So I don't want to call it a cottage industry by any stretch, but sector by sector, you do have sub-industries like you do in aviation with MRO that are focused on this, and big consumers of the data and the capabilities of CBM or CBM plus with the extended value chain. But I'd still suggest the predominant model is for the owners of assets to have these capabilities, often provided by the OEMs.
How do you benchmark how much money in your business you could be making based on the data that you're able to gather, and how much money you're able to save? What's the profitability model, kind of the benchmark of what the best companies are doing, and what would somebody exceeding that be looking at in terms of return on investment?
It's interesting when you take the asset model and concerning all these maintenance procedures, it actually tracks pretty accurately as an analogy to what we do in the manufacturing setting, where we're always concerned with the effective capacity. And we always want to create capacity within the existing assets we have. So move that over to fielded assets and condition-based maintenance, or CBM plus. It really does come down to how often is the machine not unavailable. And there may be commercial terms, like we said, service level agreements and so forth, that provide financial penalties when something's not available. But most of the economic models revolve around the operating value of the asset. How much money per hour is it producing or generating for us if it's a piece of rental equipment, and the corresponding outages. If a piece of earth-moving equipment in a mine is out of service, what's the penalty on the mine's operation or its revenue generation? And the other components, again, as usual, are parts and labor. All of those can be quantified, and we see companies actually build these models. An hour of productivity of production is worth X. So correspondingly, an hour of downtime that was not planned for also has a cost associated with it. We see these being used as the bases for justifying investments in the connectivity, the instrumentation, the connectivity, and some of the other systems associated with CBM Plus. And by the way, these are no different than what are used for computerized maintenance management systems. Most of the time when you buy those solutions, you're using the same kind of opportunity cost of a failed or a down system or reduction in labor and material. It's really no different. The metrics are the same and they're very familiar. CBM Plus simply enables you to find more value because of this extension into the supply chain.
Well, it's interesting coming from the IT world where consumption economics have been with us for more than a decade, and now heavy equipment manufacturers and their service teams are having to face this idea of providing consumptive models for the machines that they produce and service. That brings people in from the product team, from marketing, new types of skills, even HR have to come together and have a common language about transforming their business and their culture in this way. How would you advise, as a practitioner, a disparate team of entrepreneurial people in a business approach this discussion? How do you understand the basic lingo, build that framework? How do you get started?
Well, again, I think it all springs from we're all concerned with the availability of the asset. Then look at the stakeholders along the path, the owner of the asset and the incentive to connect it, the infrastructure providers with connectivity and acquisition of data, edge technology providers to consolidate data and maybe do some analytical work so that data can be provided to maybe a material services provider or a labor provider. I think the key is to build that ecosystem of participants in the maintenance of availability, reliability of the asset using these tools, figure out what their respective interests and capabilities and needs are, and then try to respond to those. This was an element of CBM Plus. They first, back in the 2002 to 10 timeframe, perhaps, the DoD looked at the participants along the continuum and asked, what do you need? They went to the Defense Logistics Agency and to all the commodity groups within DLA in aviation and ground and Navy and so forth, and asked, what are the pieces of data that you need in order to better perform your function as you measure it? Parts availability. In the logistics realm, how many times do you have to move a spare part around before it actually gets consumed, which is a measure of your planning accuracy. So they collected all this information and then sought to answer it with, well, here's what we can get from the asset itself or from the operating environment. That hasn't changed 20 years on. So an entrepreneur who's trying to build a system or a system of systems with various participants, commercial participants around this shared goal of maintaining the reliability, the availability and reliability of an asset, understand what they each need and what they each can in turn provide. And that, I think, is the key to this. And when we build ecosystems of participants around this service model, that's what we tend to ask. It's worth noting, I don't want to stray from service since that's the subject of our podcast, this series, but it's worth noting that these same data very often are used for other commercial purposes. We're, for example, heavily involved in renewables energy, and companies and individuals who have banks of batteries behind the meter are reporting the health of those banks of batteries, not only for maintenance purposes, but so that transmission and distribution parties can see what's available and can decide to perhaps turn a bank of batteries on at a certain time to shave off peak power demand. So it has nothing to do with maintaining the asset, the battery, but it has everything to do with another commercial profit motivation. So we're seeing not only service, the role of CBM and CBM Plus enhancing service capability, but we're starting to see those same principles that were so important to us be used for other commercial purposes. Just validates that, as you said earlier, Wolfie, the data are everything.
Well, Jeff, you're obviously an expert in this field, and I really appreciate you sharing some of your expertise with our listeners today. You know, we really do keep it all about service here. And if we think about how our listeners could get an understanding of how to optimize their existing services business, find incremental revenue streams, how would they connect with a company like Calypso or an expert like you to advance a project?
The best way to do that is to go to calypso.com, and you'll find resources and links there to connected operations and connected products. These are the two areas of our business where much of the technology and the business commercial interests we've talked about here today, Wolfie, reside. We work with companies in those two arenas largely around this, our smart connected operations business and our smart connected products business. You'll find both of those linked at calypso.com. And I would welcome the opportunity to answer anybody's questions, and certainly we'd be eager to help.
And listeners, I also invite you to talk to my team. My organization is all about forming ecosystems that can serve you better. Calypso is one of our premier partners and a fantastic ecosystem participant. We're here to help you with the full digital thread, and particularly the ThingWorx technologies that underpin some of these great solutions. I invite you to look for the next issue of Speaking with Service coming up very soon. And for today, Jeff, thank you so much for joining us.
Thank you, Wolfie. Great to be with you.
Thanks for listening to the Speaking of Service podcast, brought to you by PTC. If you enjoyed this episode, please subscribe wherever you get your podcasts and leave a rating or review. And be sure to check out other episodes to hear new perspectives on improving life for aftermarket professionals, service teams, and the customers they support. If you have a topic of interest or want to provide feedback, email us at speakingofservice@ptc.com or visit us at ptc.com/speakingofservice.